guys, so today is April 3rd, and I'm gonna do another Leak Code Daily Challenge. Let's start. Today's question is lowest common ancestor of deepest leaves. Okay, so it's one of those like binary tree problems. We are given the root of a binary tree. We turn the lowest common ancestor of its deepest leaves. We call that the node of a binary tree is a leaf if and only if it doesn't have any children. The depth of the root of the tree is zero. Oh, wait. The depth of the root of the tree is 0. If the depth of a node is d, the depth of each of its children is d plus 1. Oh yeah, so this is 0, this is 1. Okay, that's fine. The lowest common ancestor of a set S of nodes is the node A with the largest depth such that every node in S is in the subtree with root A. This is honestly, I don't know. This is interesting. I don't really have an idea yet. Interesting problem. So we're given this like what is it, binary tree? So we're given this binary tree, and then there's a bunch of leaves. So leaf nodes just don't have any children, right? Um, so you could kind of think of all of the lowest leaves like this are leaf nodes, but the deepest ones are the ones at this level, I guess. Okay, so there's a couple things here. They say that all the values of the nodes are unique. I'm trying to think. Yeah, I really don't have an idea yet. Oh wait, what? Return the lowest common ancestor of its deepest leaves? the deepest leaf node in the tree is 2 of, yes, right? Like this one is going to be the deepest. And then the lowest common ancestor is itself. Oh, so is it possible that this tree has multiple deepest leaves? So seven. Okay, because before I was thinking only maybe two, but that doesn't make sense, right? 10 and 11. Let's add that to a test case and see. Um, excuse me. So after 8, I want 10. Oh, wait, no. 7, 4. No, 10. So if we did this one, the lowest common ancestor would be 3, right? Let's just return none for now. Yeah, I mean, I guess that's what we're doing. We're just returning 3, which is the root. Okay. Yeah, so I don't really have an idea. This is kind of sketch, but maybe each node can pass up some information. I mean, we're definitely it's like one of those tree problems, right? So we definitely want to use some sort of like recursion to help us like traverse the tree. But I'm just thinking of what we can do. Um, Maybe we could pass the depth, and if a node will have a depth from the left and a depth from the right. Let's just say that that depth would be 1 right here, right? So if they're equal, we can say that this is the lowest common ancestor so far. So maybe we can just have LCA is equal to 2, and we'll just like keep that to the side maybe. Um, and then we're going to pass up maybe the max of these depths plus 1. So we're going to go pass up a 2, and then this one's just going to pass a 1. So now that these ones are different, since they're different lengths, we know that this cannot be the LCA, right? is that a valid statement? Like, if one depth on the left is only one, but the depth on the right was two. Yeah, right? Like, we have something like if we're currently on this one and that's a depth of one, but this one had a depth of two, like let's just say that this is the lowest leaf node and it's by itself, this would have been the lowest common ancestor, right? Or even this would be the lowest common ancestor. So we just exhausted all the possibilities of this node, knowing that this node cannot be the lowest common ancestor. So since they're like one and two are not equal, we can just skip past that. And then when we traverse up this, we're just gonna pass two, the max of one and two plus one. So that's two plus one is three. So we're gonna pass up from the left three. And then let's just say we like these, the 10 and the 11 are like real nodes. They're each going to pass one. I think it's the same idea, right? And then this side is going to pass two. This side is going to pass a one. So, oh wait, I guess we can mark 8 as the lowest common ancestor so far. I'm not sure. I need to think a little bit more about that. But we just take the max of this, which is 2, and then add 1 to it. So it's going to pass up a 3. We see that 3 and 3 are the same. So in reality, I think we should be changing. And since it's recursion, we're always going to process the root last, I guess. So if it just so happens to be the same length at the root, we know that the lowest common ancestor has to be the root. So, yeah, we could try that. I'm not super confident in that, but it seems pretty good so far. So yeah, let's start. Definitely going to use recursion, right? I could say like recurse. We could recurse on the root. Maybe lowest common ancestor could be like this for now. We know we're going to use recursion. We're going to have a non-local LCA just so that we can access this variable if we need to inside this recurse function. And we just return the LCA. So this is kind of like my plan. Oh, and then we're going to recurse on the node, right? Let me look at the constraints one more time. So we're guaranteed that there's at least going to be one. Okay. So we always want to process our node, process the node last, which means we need to traverse first. Let's traverse first. Also, we're expected to get an int, and we're expecting the max depth of a node. If not node, return 0. Right? So like how I like to think of that is, let's just say we're on this one. We are going to go to the left. And this is obviously null. So if we were at null, this should just return a 0 because there is no more nodes down there. It just returns 0. Okay, and then at this point, like this code that I'm about to write, the cool thing is it just guarantees that everything below it is well, sorry, what this guarantees is that the node is not null. So what we could do is access its left or right if we need. max left is recurse node left, max right is recurse node right. And then we want to return the max of max left or max right, but then we also want to add 1 to that, right? And keep in mind, I haven't done any, this is just returning the max, but we haven't done any like LCA stuff yet. Which I guess, I guess we could do the LCA here. If max left is equal to the max right, then we know that, right? Like let's just say we were at 4 and we called max left and max right and we got a 0 and a 0. Well, then 4 is the lowest common ancestor so far, right? So that makes sense that we would assign our LCA to be the node. And this would change later, like when we are finally at 2 and we see that 1 and 1 was actually the same depth, then we're going to change our LCA to 2. So I think this is very important. Assign the LCA when the left and right depths are equal. And since it's recursion and how we're processing it is we're doing what, like a post order traversal? Let me see, post order traversal binary tree. Yeah. Post order means we do our root last, which is exactly what we're doing. That's why we're going up and then doing our work. So finally, we'll compare at the root level whether the max depth on the left and the right were the same. If they are, that means the lowest common ancestor has to be that root. And then we're going to finally make that adjustment right here. Then we could just return LCA. Let me run this. Well, it worked for that test case. It worked for that test case. Yeah, I kind of see what I'm messing up on. I kind of see it. Wait, and then what's this? What's this one? 0, 1, 3, null. Wait, 0, 1, 3, null, 2. I'm not. Maybe on the way down, I need to consider it. I don't know. Well, the problem that I'm running into is that my code can't distinguish depth properly. Like I'm going up fine, right? And this is passing in 1, and then it's passing in 2, it's passing in 3. But at this one and this one, we pass 1 and 1 as well. So now all of a sudden, it's almost like this one and this one are on the same level, but they really aren't, right? Like this one was deeper. Um, so how can I fix that? Maybe we need to do some work going down. If we did some work going down, we can like name them, right? Okay, 3, 3, and then we get back a 0. We're gonna get back like a bunch of zeros right here. And then if it was the max level, zeros, if it was the max level. Hmm. If it's the max level. Um, Maybe like this is like the max level that we've seen so far. I don't know, this is interesting. I haven't done something like this before. Maybe I could pass 0 whenever we recurse the max level that we've seen. It just goes up by 1. So now when we go down to the bottom, if the max is equal to, and now we're starting to go up, right? If max left and max right are equal, max depth is 0. Max depth is the max of itself, or the max level seen, and the max level seen is equal to max depth. I don't know. Hmm. So this was my original, so I'm scratching that idea. Hmm. Two, two. Because I'm trying to think if I did it in this way, and let's just say, yeah, we still had like two nodes over here, then if we were counting the depth, it would be 3, 3. So not only should we, okay, so not only should we be passing up these numbers, but we should also be passing this like max depth, which I kind of had that idea before, but I didn't express it. So expecting the max depth of a node. Yeah. So we want to return this as well as some sort of max depth, right? If not node returns 0. Ah, also max depth cannot be, there could be like a max depth, like a global. I guess there could be a global, but it shouldn't be the same as this one. This needs to be the max level scene. If not node, you want to return 0 and scene. Else keep going down and keep increasing max level scene. Once we hit the bottom, if max is equal to this and this, and max I guess this could be cur level, right? This is the cur level plus 1. Cur level plus 1. Max level on the left. Max level on the right, the max level that we've seen on the left, the max level we've seen on the right. And then I guess the max level is just the max of the left and right levels. So if max left is equal to max right and max level equal to the max depth, when we're at the very bottom, max depth is equal to the max of itself or the current level. Update the max depth. Okay, now that we make sure that we're only doing the when the max level is equal to the max depth. And then what are we going to return? Max level, right? Okay, I think, well, I think it's like that. I'm not sure. Okay, that worked. Okay, cool. Honestly, I kind of used up like 100% of my brain because I'm not comfortable with that solution. Uh, just because I don't think I could explain what I'm doing exactly, which is pretty bad. Um, but I mean, there's probably cleaner ways of expressing what I'm doing. But the general thing was before doing all this like max depth stuff, like this made sense to me. And I think it still kind of makes sense, right? Like if you have um if you have the depth of your left is x and the depth of your y is y, and you're currently at this like node right over here, as long as x is equal to y, then we know that we found the lowest common ancestor. But the only problem is that in like the grand scheme of things, uh what if the lowest common ancestor actually, what if the depth actually went lower, right? Like down over here, like super far down, then this shouldn't be the lowest common ancestor anymore. It actually should be this. That's because this depth is so much bigger than just this small depth over here. And that kind of hints at we need to, while we recurse downwards, we need to kind of keep track of this max depth. Going level by level, we're currently adding +1. So when we finally reach to a node, what we can do is just say, we still do that same check, like is x equal to y? Is the max left is equal to the max right? And our max level, because we'll be keeping track of the level so far, and if this is the farthest down that we've seen before, max level is equal to max depth, then go ahead and change our LCA to point to the lowest thing that we've seen. And that even works when we are met with a tree like this, that the max depth or the lowest common ancestor happens to be the root. And that works because the you see the 3 and 3, those are equal, right? Like x is equal to y. So that part of the condition passes. But also, what about the max level and max depth? Well, the max depth is a non-local variable that we've been counting as we traverse down. So we know globally that the max depth is 3. So that's cool. And then what about the max level? The max level is something that gets passed back to us whenever we recurse. So since this root is the last thing that gets like assigned right over here, we are expecting the max level on the left and the max level from the right to be something, right? And it's going to be um, what it's going to pass back to us is the max level, which is just the max of the max level left and the max level coming from the right. So it's going to be passed back a 3, passed back a 3. And we know that 3 is the maximum depth. So it is the maximum level, right? So this whole condition passes. So then we can assign LCA to node. Honestly, I did it kind of confusing, obviously. Um, but yeah, what's the time complexity? I mean, we just visit the node once, right? So I believe this would be O of n time O of n space, because we just use recursion. Let me look at the editorial. Yeah, we're using recursion. Oh, I guess there's a much easier way. But I'll have to study that on my own. Huh. Actually, let me see. If not root, return 0, none. Left is DFS, right is DFS dot. Okay, yeah, so we're doing the post order traversal. If left at 0 is greater than right at 0, return left at 0 plus 1. And return left at 0. Oh yeah, I have no clue what that's doing. But yeah, hope you guys enjoyed the video. Kind of sloppy today, but it's cool. At least we got it done. Thanks for watching.